Yes, I need them to be able to record it so they can watch it.
Are they gonna have a sub?
I hope they have a sub. The last class didn't have a sub show up and then didn't tell nobody. And then when a kid tried to go tell somebody, they like threatened the kid.
Oh, that's.
Yeah, Van just left.
We were supposed to have a sub, but the sub went to the wrong room. We just sat in there.
All right, you ready? Good morning, Geo Metro Ninjas. Welcome to another exciting day in the world of quadrilaterals. Today we get to talk about kites. Now, we're not talking about Benjamin Franklin and how he flew a kite in a thunderstorm to discover electricity. We're talking about mathematical kites. So kites are still quadrilaterals. How do we know kites are quadrilaterals? They have four sides, absolutely. So the biggest difference between kites and what we've been talking about between parallelograms, rhombi and squares, rectangles, or even trapezoids is in our kites, none of our sides are parallel. So remember our parallelogram family, they had two pairs of opposite sides that were parallel. In our trapezoids, we had one pair of opposite sides that were parallel. For kites, nobody is parallel. We do have short legs and long legs, and then I'll call them skinny angles and fat angles. Okay? So one pair of opposite angles are congruent. That's our fat angles. That's where our skinny, our short sides, and our long sides come together. So if you're looking at this diagram, that would be these guys through the middle. So it's where my short length and my long length come together. Those are always going to be congruent. Much like our rhombi, the diagonals are perpendicular, which means they intersect at a right angle. And remember, if one angle is a right angle, all four of them are. Our short sides and our long sides are congruent. Okay, so the tops and the bottoms of our kites are congruent. That's our short legs. So like if this was 12, 12, then this one was 24 and 24, or 25 or whatever it needs to be. Those are our consecutive, meaning next to. And the last property of our kites is that where our congruent sides come together, those two are being bisected. Not these ones up top, not our fat angles, but only where our congruent sides come together, both of those pairs. So realistically, a kite is just four right triangles. You can kind of see them here. Our four right triangles that are formed inside of our kite. The top right triangles are congruent, and the bottom right triangles are congruent. But even more so, what shape would this figure be? It's still a triangle. It's got two congruent sides instead of three, which is what kind of triangle? Isosceles, absolutely, great job. So our isosceles triangle, what do we know about isosceles triangles? Equal sides, good. What does that mean about our angles? Two equal base angles. So we're going to use that a couple of times. So realistically, a kite is just a whole bunch of triangle math over and over and over and over. I know we're excited about that. All right, let's go ahead and get our first question out of the way. So it wants us to find the measure of 1 and the measure of 2. So when they don't tell me that these are congruent, it's hard to tell sometimes because sometimes the picture gets a little wonky on me. But I know that these are my fat angles because these aren't congruent. There's only one pair of congruent angles in a kite, and that's generally our fat angles. In this case, 1 and 2 are where my two different congruent sides come together. So those are both unknown. Since they're both unknown and both congruent, I'm going to let the same variable represent 1 and 2. Now from here, we've done a lot of quadrilaterals, so some of us might already know what the interior sum of our angles are. But if we do not know, we always have the formula S equals 180 times n minus 2 at our side. So remember, n represents the number of sides. Okay, so n represents the number of sides. In a kite case, a kite is a quadrilateral. Excellent. And quadrilaterals have 4 sides. So 180 times 2, we know the interior sum has to be 360. And again, maybe some of us are beginning to recognize that quadrilaterals are 360. That's great. If we're not there yet, S equals 180 times n minus 2 will always work for us. So now that we know what all of our angles add up to be, we can add them all together and solve for x. So we have x plus 78 plus x plus 32 is 180 degrees. All 4 of those angles together combine to be 180. We're going to combine like terms. So there are 2 x's plus 110. Nope. Yes, 110. Fix me if I'm wrong, so we don't put wrong information out there on the internet. Oh, see, y'all didn't. It's not 180, it's what? 360. Thank you. See? You can, hey, fix me. We all make mistakes. So 360. I knew something was wrong from earlier. Okay. So now we're going to go ahead and subtract 110 from both sides. Two x is 250. And then we divide by 2. So x is 125. Did you get your question answered? Yes, perfect. If we have a question, questions are good. That lets the other class know that there might have been some questions, or anybody else watching on the internet that's like, man, that Coach Oliver dude can really teach math. 7. On average, it gets about 7, even though I tell a whole class of 24 to watch it.
They don't put it up on.
They do sometimes. Depends on the sub. All right. Number 2. Given that AB is 12 and BC is 20, find the length of AD and CD. Well, this is a kite. In a kite, we know that consecutive sides are congruent. Since AB is not congruent to BC, that is not my pair of consecutive sides. That means 12 is my short sides and 20 is my long sides. And if AB is 20, AD has to be, or AB is 12, AD has to be 12. And then simply stated, BC is 20. So that means CD is 20. And there's nothing else we could do on that one. We don't have enough information to find any of our diagonal lengths. We would need something else. If we had an angle, we could use SOHCAHTOA, but we don't have anything but 90s and hypotenuse. Hey, what's wrong? You good? Hey, you all right? Appreciate it. Angle H is 8x minus 16. And angle F is 6x plus 20. Since this is a kite, there's only one thing that can be true here. In a kite, only one pair of angles is congruent. There's no way we could find these lengths with the given information. There's not enough. So the only option we have is to know that these are our congruent angles. So we're gonna set them equal to one another. 8x minus 16 is 6x plus 20. So if you get to your homework and you're like, why do they only give me two things? There's a good chance they're only giving you two things and they have to be equal. Unless they're putting it like two angles inside of a triangle where we know the third angle is 90. Only two angles inside of our kite. The only thing we could possibly do here is set them equal to one another. Same thing if they gave us like sides up here. The only thing we could possibly do is set them equal to each other. Like this would not be equal. Right? We would have to have these two. So for kites, we can use a little bit of our deductive reasoning to kind of figure out what they want us to do. All right, we got a variable on both sides, so we always move our variable first. Subtract 6x. 2x minus 16 is 20. After we go ahead and isolate our variable, now we can move our constant. Plus 16. 2x is 36. And then now that our variable is all by itself, we can go ahead and divide by that coefficient of 2. And then 36 divided by 2 is 18. Number 4, find the measure of BEC. Remember, when they write these out, it's like a road map telling me how to travel. So start at B, go down to E, finish at C. Well, since this is a kite, the diagonals do what? They're perpendicular, absolutely. And if my lines are perpendicular, that means the angle has to be 90. Easiest question on the paper. Don't let it trick you. Again, that's all we could do with this question. There's nothing else. We don't have any more information to be able to find any of our angles. All we could do is say that that's 90 with the given information. All right, number 5. AE is 6. BE is 10. Find the length of AD. Now, here's where we got to go back to an old friend. So this guy right here in the middle, what specific triangle do we have? A right triangle. Absolutely. Specifically, we have a right triangle. Now remember, for a kite, we know that these sides are congruent, which what would that tell us about these two triangles? If we know this is congruent and we know this is congruent, side, side, side tells us what? These would also have to be the same. So we can go ahead and rewrite our 10 down here, or I could have rewritten the X up top. Doesn't matter. You can move it either way because AD is going to be equal to AB or BE is equal to DE. Doesn't matter. Now that we know 2 of 3 sides of a right triangle, which one of our mathematical theorems do we use to find the missing one? Pythagorean theorem. Biggest importance is we identify the hypotenuse first. Always identify your hypotenuse first because A and B does not matter. Right, so we're going Pythagorean theorem, A squared plus B squared is C squared. Remember, if we know 2 of 3 in a right triangle, Pythagoras is our friend. Oh, zooming in late. Okay. So we're going 6 squared plus 10 squared is x squared. $36 plus 100 is x squared. Go ahead.
How do you know where to put A?
A and B don't matter. C is the one we identify first. So remember, we look at our right angle, and across from our right angle is always our hypotenuse. So that's always C. And then A and B, we can choose whatever side we want.
Okay.
So 136 is x squared. And then the only way to get rid of a square is a square root. And then we can reduce 136. 136 breaks down into 2 and 78. Yeah. And then 2 and, I do math in my head. 39? No. Yes.
No, it's 136 divided by 2 is 60.
68.
136 divided by
68. So this is 34, right?
34.
And 34 is 2 and 17. Okay. This is where we look for pairs. We got one pair of twos. So that one comes out. So we get 2. And then what number is left under the radical? We've got a 2 and a 17. We pulled them apart with division. So we put them back together with multiplication. So that length of that side is 2 root 34.
Why is 34 not 17?
Because there's still a 2. We have a 2 right here that doesn't have a partner, and there's a 17. So you put them back together with multiplication. Because realistically, it's this number right here, right? That's why that 34 is still there. Yes. I want you guys to default to the exact answer. And then if they want a decimal, I have 100% confidence you can put that number in a calculator. But I want y'all to get good practice with reducing your radicals, because when you get to algebra 2, you're going to have more radical answers. Because they're going to really start hitting y'all with stuff like this: 18x cubed, y to the 6, z 12. And they want you to reduce that. Yeah. So that's what's coming. So that's why I'm trying to get you guys used to it. And this would just be 3x y squared z6. And then you just have a 2x inside.
We did that.
You did a little bit of that last year, but when you get to algebra 2, you're going to do a lot of that. I know you look excited. I can tell. No, because you get to divide and you get to multiply and divide rationals next year. So you want to cancel out as much as you can early to make your lives easier. It is. It's tote lit, fam. All right. Stay with me. Y'all are doing great. 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 Okay, so QS is 40 and UT is 21. They want us to find the length of ST. Like I said at the beginning, it's going to be a lot of triangle math because it's just 4 triangles put together. That middle diagonal is always going to be bisected by our long diagonal. So this piece is 20. And then what shape is formed? It is a triangle, but specifically because it's a kite, it's a right triangle. If we know 2 of 3 sides in a right triangle, we can always use Pythagorean theorem. So a squared plus b squared is c squared. So remember, x is not always going to be our c. C is always where? Across from the 90. C is always our hypotenuse. The last two X has been C. That's great. It's not always going to be the case. The only always I want you to worry about is that the 90 is always across from the hypotenuse. The longest side always across from the longest angle. Then again, A and B do not matter which one you label because they're getting squared and added together. So 21 squared plus 20 squared is X squared. 21 squared is 441. And then 20 is 400. And then we add those two together to get 841. And then the only way to get rid of a square is a square root. And when you square root 841, always pop it in your calculator, make sure it's going to come out to a nice pretty number, is X.
If it does come out to a nice and pretty
So your next is a test, and it'll either say put in exact answers or put in a decimal, but then remember our tests are multiple choice. If it was a quiz, it would say leave as exact. And if you give me a decimal, I usually just take off half. Again, I need y'all to practice your radicals. You're going to have to be able to do radicals when you get to algebra 2. All right, next page. We'll do a couple more and then I'll set you free for your homework. Hey, number 7, find the measure of angle 1 and the measure of angle 2. So because this is a kite, the diagonals intersect at 90. So I know that these are 4 right angles. That is always true. Because it's a kite, I know my skinny angles are bisected. So if one piece is 29, the other half also has to be 29. And then remember at the beginning when we talked about isosceles triangles here, if this is an isosceles triangle, which we know consecutive sides are congruent, then my base angles have to be congruent. So without doing any math, we've got a lot of our triangles filled in. But we are going to have to do some math to get to it. One would not be 18 because the fat angles are not bisected. The fat angles are added together to create congruence on opposite sides. So K would be equal to M, but the individual angle itself is not bisected, only your skinny angles. The fat angle is always in the middle. Yep. Because it's where your short side and your long side come together. So that angle they're creating is going to be consistent. So to find the measure of 2, okay, we've got 2 options. We know the inside of a triangle always adds up to be what? Inside always adds up to be what? The inside always adds up to be what? 180. Okay. So we can do our triangle sum theorem, which most people are comfortable with. So the measure of angle 2 plus 18 plus 90 is 180. So when we combine like terms, the measure of angle 2 plus 108 is 180. Subtract 108 from both sides. So the measure of 2 is 672. That's the normal way that everybody goes. But remember, we have that complement theorem. 2 and 18, when they add up, have to equal what? If we know half of the triangle is already taken away with a 90-degree angle, what is left for those 2 to be? So these are complementary angles. And complementary angles always equal 90. If you're not comfortable with that, don't worry about it. But if you can recognize that pattern, it might save you a little bit of time. And then we're going to do the same thing now to find angle 1. Right. Again, we have a right triangle. I know that because it's a kite, and in a kite, our diagonals are perpendicular. So the measure of 1 plus 29 plus 90 is 180. Combine like terms, measure of 1 plus 119. I think that's right. Subtract 119. So 1 is 61. You could just subtract 29 from 90 because those two have to be complementary because 90 is already taken up by them. But what we're most comfortable with is the triangle sum theorem. Triangle sum theorem is not going to get you sideways. Complement theorem won't get you sideways either. But some people don't recognize that as easy. Any other questions on 7? All right. Solve for x, given that EJF is 6x plus 6. So EJF is 6x plus 6. Since this is a kite, the diagonals are perpendicular, which means they intersect at 90. Well, if one angle is 90, what's the other one got to be? 90. So we're just going to 6x plus 6 equals 90. Again, layup. Shouldn't miss it. It'll probably show up. Minus 6. 6x is 84. Divide by 6, not x, goofball. So x is 14.
So why don't you equal it?
So first things first, I would have to double it if I wanted to set it equal to 180. Because it's talking about specifically EJF, this is 90 degrees. So I know that if this angle's 90, then that's what that has to equal to when added together. I don't want to make my life more difficult. Okay. Number 9, EMF. Okay. Right triangle, nice and pretty. Okay. Are these two angles congruent with one another? They are not. Okay, they are not. But are these two angles both within a triangle? Yes. And if we know all 3 angles on the inside of a triangle, those should add up to be what? 180. This is where that complement theorem, you could also just set them equal to 90. But if you don't recognize it, don't worry about it. 3x plus 2 plus 12x minus 17 plus 90 is 180. You good? Combine like terms. So 15x, and then we get 2 minus 17 is negative 15. Negative 15 plus 90 is 75. Y'all math me. Make sure my math is mathing. Feels right. Subtract 75. So 15x is 105. And then divide by 15. So x is, of course, 7. All right, and last one I want to do with you guys is this because I think it's number 2 on your homework. Hey, it wants us to solve for x. But those tricky rascals only gave us 3 angles. Or did they? What do we know about H and F? The fat angles are congruent. So my 75 can also be rewritten over there. Now I know all 4 angles inside of my kite. If I didn't know all 4, there's nothing else I can do. Now, what I saw some other classes trying to do is like put diagonals in there. Don't do that. Don't make your life more difficult because we don't know how this is being cut up. And then this being bisected doesn't have any relation with that being bisected. So don't make your life more difficult. Go with your standard add them up quadrilateral. Yes. That's fine. So that would be 71 and D is what you don't know. So D would be your X. Yeah, sometimes they kind of turn your kite on its side to try to mess with you. So 3x plus 2 plus 75 plus 7x plus 8 plus 75. And then the inside of a quadrilateral always adds up to be 360. What, coach, what if I forgot that? Remember, you can always do S times 180 or S equals 180 times n minus 2. And we get 180 times 4 minus 2, which gives us 360. If you do not remember, you can even do that for triangles. If you like blank on what a triangle adds up to be, 3 minus 2 is 1. 180 times 1 is 180. So S equals 180 times the number of sides minus 2 works for every polygon that we know in existence. And even the ones we don't know about yet. Okay, so we combine like terms. So we get 150 plus 10, so 10x plus 160 is 360. Yep, 2 and 8 is 10, 75 and 75 is 150, 150 and 10 is 160. Subtract 160 from both sides. 10x is 200. And then we can divide by 10. X is, knock that 1 0 off, X is 20. Any other questions we have?